let's start by going over what we learned last session. Hopefully you all picked up on what I taught, and if not, hopefully you have already reached out to me. So the first thing that we tackled were the sum and average formulas, and here they are. Summing rows or columns, you always start with an equal sign, equal sum, open parentheses, the starting cell, colon, the ending cell. And that sums all the numbers in between the two cells. Or you could do something like this, equal sum cell 1, comma cell 2, comma cell 4, comma cell 8, all the way down the road, no matter how many cells you want, and that cell sums only the ones that you choose. You could also do averages, very similar. Equal average, starting cell, colon, ending cell, that averages all the numbers between those two, or equal average, cell 1, cell 2, cell 8, cell 10, cell 16, with comma in between, and that averages only the cells that you chose. Percent and percent change. Percent's pretty simple. Equal, open parentheses, the small number, so cell 1, divided by the denominator, cell 2. And that finds what percent of cell 2 is cell 1. Percent change is a little bit more complicated, and we went with the no. Journalists don't like math, no. So it's new minus old divided by old. So here it is, equal, open parentheses, new cell, so the new value, minus the old value, close it, divided by the old value. And that's percent change. And of course, for all these and for all formulas in Excel, you can lock cells. And that's by putting a dollar sign before the letter and then before the number of the cell. That locks the cell, so you could copy that formula or replicate it down the row, but it always refers to, in this case, A1. So that's a quick review. Let's move on. Okay, moving on, let's learn some new formulas today, maybe 3 or 4 of them. So if you haven't already, go online and download this file. It's a CSV file called incident_2018. Throw it in today's folder inside your data folder class, and practice safe computing. Copy that CSV file, label 1 original, and open it up. So you're going to open up incident_2018. And while you do all that, I'm going to open up the file right now and go over it with you. You can see it opens up like an Excel file, but it's actually a comma separated value. And I'm going to spread out the columns and tell you what we have. Now, I get this data regularly from Charlotte-Mecklenburg's police department, and what it is every reported crime, in this case for 2018. I'm going to scroll down and see how many, give or take, reported crimes we had. And I fiddled with this data a little bit, so it's not exactly accurate, but it'll do the job. It looks like we have, what, 94,000, give or take? Not bad. And I'm going to scroll back up and go over the fields with you. We start off with some address information. So the street number, street direction, you can see we have an east and a west, an east and a south. We go up with street name, street type, in this case it's a road, a drive, place. We have the city that the incident happened in, state, zip code. We have the offense date. Now check out the offense date. Looks like it's a date followed by perhaps a time stamp as well. So as a data reporter, I'm looking at that thinking, okay, I'm going to have to clean up that field before I use it for any sort of analysis. We have a location of the incident, a place, sort of a general location, and then place 2, a more specific location. Instead of open area here, it says street or highway. Instead of residential, it says private residence. So a little bit more specific. Scrolling over, we have a case close date. We have a case status field. We have a column that lists all the offenses, and I'm going to scroll down just to get an idea. Looks like affray, aggravated assault, all other offenses, all other thefts, burglaries, credit card, fraud, vandalism, etc. So we'll check out that. And then a value field. And most of the value fields are blank. Let me see if I can find some that are actually populated with a number. I'll do a Control F. Here we are. So it looks like all the thefts might have a value associated with it. So there's some thefts, more. So we might play around with that field as well, just to get an idea of what sort of dollars we're looking at, motor vehicle theft, etc. Okay, so this is our data. Again, you have an original backed up for you, and let's do something that should be a review for us. It'll start out as a review actually, and then we're going to add one extra step. Let's concatenate the street number, direction, name, type, city, state, and zip. Right? Take all those fields, mash them together into one general address. Okay, so I'm going to create a new column, and I'm going to create it right where H would be. And if you have forgotten how to create a column, you click on H, and then you right-click and insert. There you go. I got a new column. Everything shifted over one. And I'm going to call this full underscore address. And I'm going to spread it out. Now, feel free to jump ahead if you remember how to concatenate fields. If you need a little bit of help, follow along. And what we're going to do here is concatenate all these into one address field. Here's how. Equal concatenate, Shift 9 to open, then we march down the row. Remember, it's the one cell, ampersand, quote, space, quote, ampersand, the next cell. And you go all the way down the G, and you can see that my field's lit up, or my cell's lit up, so that means I'm sort of on the right track. I'm going to close it by doing a Shift 0. And what I'm also going to do is I'm going to add commas before and after the city, because usually it's an address, comma, Charlotte, comma, North Carolina. So I'm going to add a cell before and after the city. And to do that, the city is in the E field, so I'm going to add a comma right there between D and E. So it's going to go ampersand, quote, comma, space, quote, ampersand. And then I'm going to add one more, the same spot, following the E field. So take a second to look over that formula, match yours up if you can, and once you do, hit enter. Okay, now because this is a CSV file, at least my version doesn't copy it all the way down. So if yours didn't copy it all the way down, double click on the magic box in the bottom right hand corner, and there you go. Now, double check this too. If you happen to have an older version of Excel, and if you double clicked on the magic box and it only copied it down a couple rows, sometimes when Excel sees a blank just to the left of the field that you're working on, so in this case, when it sees a blank in G5, it'll stop. And if it did stop, just grab that little square, click on it, and drag it down manually. It's kind of a pain, but it'll do the same job. So just drag it down as far as you can go. Okay, I'm going to save this since looks like I successfully ran a query. And it's saving now. And what I did is concatenate all the address fields together. Now I'm going to spread out my column. Uh-oh, look at that. This is going to take some cleaning, huh? It's reading the columns great, but hey, data is dirty. And here's how dirty it is. If I were to click on, Charlotte, and then just put my cursor up here and click, or put it in anywhere in the box with Charlotte after the word, you can see that my cursor doesn't automatically back up to the E. It sometimes goes way out here, and way out here, and way out here, and so it's not tight with the E. And what that tells me is there are a number of spaces, blank spaces, after the word Charlotte. And there are a number of blank spaces after the street names, in this case Albemarle or Amity. Right? That's not good. And there's even some blanks in between or after the block number. So we sort of concatenated it, but it needs a little bit more work because that just looks ugly. And we would never run something like that in the paper where it's 301 East 7th, 15 blanks, Street, comma, Charlotte, 15 blanks, comma, North Carolina, 28202. So let's clean it up. And it's not tough to clean up if you know what you're doing. I'm going to save this if I haven't already. And then I'm going to create a new column just to the right of H. And I'm going to call it full address final. How about that? So highlight I, select insert, and that gives me a new blank column, everything shifted over one. And I'm going to call it full address final. All right. I'm going to save it again. I like to save a lot. I'm just sort of weirder like that. I've lost enough data in my life to know not to do it again. And we're going to use the trim function. And what trim does is the trim function, or the trim formula, eliminates all unnecessary blank spaces. Right? And it's a super easy formula, just like the uppercase, lowercase, proper, etc. The trim function goes equal trim, and you can see Excel sort of gives me that option, so that's great. Shift 9 to open it. Then click in one of those ugly address boxes that we concatenated. In this case, click on H2 and close it. So we have equal trim, TRIM, Shift 9, the cell that we want, which is H2, Shift 0 to close. Now hit enter. There we go. See, it trimmed all those unnecessary spaces. Take that and copy it down. We'll see how far it goes. Much better. Look at that. Just one extra step, and we cleaned up all those records. Now we have 6800 St. Peter's Lane, Charlotte, North Carolina, 28105, instead of all those blanks. Okay, so that's the trim function. Equal trim, open parentheses, the cell you want, close it, copy it down. Now I did something else good, so save it. Okay, perfect. Great, it's all saved. I'm going to X out this little warning that doesn't mean anything. And say you're a reporter and you got a tip that said it takes forever for Charlotte-Mecklenburg police to close cases. Now, maybe that's accurate, maybe it's not, but it might be worth checking into. So let's see if this data can help us with that. I'm going to scroll over. Now we have an offense date, so that's good. And I thought we had, yep, we have a case closed date, right? And we want to find out, just to explore, how long it is between an offense to the time that it took Mecklenburg County to actually close out the case. So there's a couple functions that we can do for that. But first, we sort of have to clean up this offense field. We have to get rid of the timestamp. In this case, the 1557 or the 0754. So let's clean up this field. So highlight K, click on K, right click, and insert a new field. And I'm going to call this one offense date final. Offense date final. That's normally how I label fields, either field 1 working, field 2 final, field 3 new, something like that, just to know that it's a working in progress. And we already learned it, but how do you think I would take this field, the offense date, and eliminate that 1557? What function that we already learned do you think would do that? Any ideas? What about the left function? If we grabbed the first 10 characters to the left, and that's all we grabbed, and we put them in this cell, it looks like we would leave out the blank space and then the 4 numbers following it. So let's try it out. You remember the left function? Equals left, open parentheses, the cell you want. Now the number of characters, in this case it looks like 10. We have 2 for the month, 2 for the day, 2 for the year, or 4 for the year, which is 8, and then a slash and a slash, which is 10. Close it out, hit enter. Okay, perfect. We were right. Now copy that down. And let's just make sure it copied down. Looks good to me, looks good. Okay. So that was the left function coming in handy, huh? Now I'm going to save that because I did something good. And now what I want to do is calculate the time between the new offense date field, the offense date final, and the case close date. So I want to calculate the time between those two dates. How would I do that? Well, there's a function in Excel called dateDiff. So if we want to find the time between this date and this date, or this date and this date, that's what we use the dateDiff function for. So do me a favor and highlight P and do what we did before. Right click and insert a column. Insert a column. And what I'm going to do is type the header time underscore in underscore days. Now the dateDiff can measure days, it can measure months, and it can measure years. And I'll show you the difference. But here's the dateDiff function. Alright, we always start with the equal sign, or at least we have so far. Equal dateDiff. D-A-T-E-D-I-F. Then we do what we usually do, Shift 9 to open the parentheses. And in this case, we do starting date comma, ending date. So our starting date is when the offense actually happened. Then we comma. The ending date was when the case was closed, comma. So far we have equal date diff, open parentheses, starting date, comma, ending date, comma. Now in this case, there's not a large time in between the two dates. You know, it's not 10 years or 6 months or 3 decades. So I would measure it in days. And to measure in days, after your second comma, you do quotation mark, D, close quote, and then wrap it up by closing your parentheses. So let's go over that real quick. We have, just lost it. Okay, here it is again. We have equal date diff, K2, comma, O2, starting date, comma, ending date, quote unquote, D in the middle. And that's measuring in days. Hit enter. Okay, and you get something crazy like that, right? You get 1/0/1900. Now that doesn't make sense to me because I thought I was measuring how many days elapsed between when the offense happened and when the case was closed. So something's fishy, and I'm looking at my format for this field, and it's formatted as a date because I was working with dates. So Excel thinks that, okay, this one's going to be a date too, which we're smarter than Excel. So I'm going to highlight the P column. I'm going to go to my format drop down, and rather than date, I'm going to select text. So I'm changing that time in days to text. And all of a sudden a 0 pops up. Now that might just make sense because look, the first offense date was 11/6/2018 and the case closed date was 11/6/2018, same day. So take that one and copy it down. And again, if yours doesn't copy down by clicking that magic box on the bottom right, you might have to unfortunately drag it all the way down. I have a newer version, so mine clicks down and I'm looking at it. Sort of looks like it worked, right? But I do get a bunch of errors. Now let's go back and look. First, let's tackle the errors. Why might this be an error on P10 or P14? Well, it's an error because there's no case close date here, or here, or here. So whenever there's no case close date, or probably no offense date, Excel is saying, hey, wait, I don't know what to do, so I'm just going to mark it as an error. But that's fine because we can't make up a date. We don't want to make up a date. So the errors kind of check out. Let's see if the actual math checks out. So we knew the first one did because they both happened on 11/6/2018. The next one says there were 27 days in between the time of the offense and the time the case was closed. Now I'm sort of doing the math in my head. You have 2/18 to 3/17. That sort of makes sense, right? There's 18, so that would be another 12 or so days, plus another 17 or so. Maybe you had 31. Okay, let's do an easy one though that we can kind of eyeball. What about this? What about P9? It says there are 11 days in between the dates. So this one happened on 11/15 and it closed on 11/26. 11 days. And we can even do just a fact check ourselves. Look at P13. That said 8 days. So we go from 2/15 to 2/23. Looks good to me. See, we just measured the time in days, and now we can look at the data to see not only how often CMPD closes cases, how often they arrest people and give the victims of these crimes sort of justice, but also how long it takes. So that's the dateDiff function. Super helpful for easily measuring the time between two dates. Now, I'm going to highlight my P2 real quick just to bring up the function again. If I were to measure these 2 times in months, I would simply take that D and type in an M. And this is going to measure it in months. And if I was going to take it and measure the years between, I just substitute a Y for a year. So the dateDiff can measure time in days. Now we just found the number of days between when an offense happened and when CMPD closed the case. Now if I want to do some sort of analysis on this, like find the average number of days it takes CMPD to shut a case, I unfortunately have to save this file, close it out, and reopen it. And the reason why is right now, even though it's a CSV file, Excel is treating it like an Excel file. Like if I were to click on this 27, it's not a 27 number. You know, it's reading it as a formula. So I wanted that 27 to be an actual number. So I'm going to save the file. And remember, when I save CSVs, it gives me a lot of, and close them out, it gives me a lot of are you sures. Exit out. Let me see if this works. I'll open that file back up. And I'm going to see if the data that we were working with, the time in days field, is a formula still, or if it is that actual data number. Scroll back over to column P. Now double click on 0. See that? It just says 0. Or double click on 27. Oops, mine jumped all the way to the bottom. There we go. Double click on 27. Double click on 34. See what the CSV file does? I think I mentioned this in the last class. It gets rid of the formula behind the scenes, and it's only reading the data in that field. Right? So now I can play around with that field, but before I do that, I'm just going to clean up some stuff that we did. And I don't need this original offense date, column J, because column K has it. So I'm going to delete column J. If I would have deleted it in Excel, it would have deleted column J as well, because J was reading the previous column. Does that make sense? And I'm also going to delete H, my old concatenation, G, F, E, and down the row. And the reason I'm going to delete all that is because I have the full address all together and cleaned up in one field already. So right click on a line in between the G and the H, delete. See that? The Excel would not have let me done that. If I did, it would have screwed up my full address final column. So now I have full address final, offense date final, and then time in days with just the data being read. So we're going to use the average formula, which we learned before, to find out the average number of days it takes for police here to close a case. Now the one step that I have to do before I actually average is if I try to average a value or an error like these two, it's going to give me an error on my result. So I have to get all the values sort of grouped together. And the easiest way I know how to do that is just to sort them. So I'm going to select all, sort, custom sort, and I'm going to sort by time in days. And for the heck of it, I'm going to do smallest to largest. I could really do either one. Okay. So that sorts. It looks like I get my numbers first. We'll see if it increases. Yep. Now these were closed in 1 day. And then after that, I got 6, 12, 27. Then I get my values at the bottom. So I'm going to write a query to find the average number of days it takes for CMPD to close the case, but I do not want to include those errors, in part because the cases were still open, but also because I would get an error on my result. So I'm going to scroll down to the final one before the error mark, and here it is. And this is row 37, 27, 6. 37, 27, 6. So scroll all the way down to the bottom and leave one record in between your data and average those days. Remember how to write an average formula? Equal average, shift 9. In this case it would be G2, because that's our starting value of the second cell, colon, to the last cell that actually had data in it and not an error. And if I remember correctly, it was 37, 27, 6. And that would be G, 37, 27, 6. Okay, let's close that. So you have equal average G2 colon to G 37, 27, 6. Hit enter. There we go. So we could have a sentence in our story, if this is a legit story, that says, on average, Mecklenburg County closes cases after 17.7 days. Something of that sort. And of course, some of these cases are still open, so we'd have to include that in our story, that X number of cases, however, remain open. But that's the number of days, on average, it takes Charlotte-Mecklenburg Police to close a case. 17.7. Now another sentence that we could write is just the sheer number of cases that are closed. Now we have in this data 94,170 incident reports. And on average, for a closed case, it's 17.7 days. Let's select all, I should say, and sort it by case status. Custom sort, case status, maybe A to Z, we'll see if that works. And you can see that my value for the average is all screwed up now. So I would have to write that 17.7 down in a notebook because I resorted the rows, and now my formula is looking at some errors or some of those value formulas. But that's alright for now, because I'm interested to find out how many total cases CMPD has closed. And it looks like they start up top. That's good. So of the 94,000+ cases, CMPD closed, I'm scrolling down to find it. How many? Sometimes it takes forever when you're actually looking for the specific cell. There we go. So that might be another sentence that says, it looks like around 1/3, that CMPD closed around 36,000 of its 94,000 total cases last year. And I know it's 36,000 because you can see right here it says my cursor was on the cell E, 36,415. So that's another sentence that we could write. That CMPD closed roughly 1/3 of its cases last year, and for those cases it took on average about 17 days. Interesting, huh? Now let's switch gears a little bit and let's learn an if-then statement. That's another type of function in Excel. So do me a favor and scroll over to the D column where it says the place. right up there. So place 1. Now say in our reporting we're really just interested in residential crimes, right? We're not interested in open areas, we're not interested in public or non-residential, commercial places, retail, etc. We're just interested in residential. And we think it would be easier for us anyway, to do our reporting if we had a column that said whether a location was a resident or residential or non-residential. So let's do that. Because I've worked with this data before and we sort of already got a glimpse of it looking at the address locations, I know that there's a bunch of blank spaces in the place 1 column. So we'll have to get rid of those blank spaces before we actually run our if-then statement. You see how my cursor is way far away from the A? So we need to trim all them. So let's run another trim formula. And to do that, I'm going to create a new field, insert, right next to place 1, and I'm going to call it place 1 final. Creative, huh? And run a trim formula on the old place 1 column. Can you do that? Equal trim shift 9 D2 close. So we have equal trim shift 9 to open the parentheses, D2 to grab the cell, and we close it. Hit enter. Now this should trim all of our blank spaces, even though we can't really see them, but now the data is there and we can run our if-then statement without any errors. So how do we do that? Well, let's do what we've been doing all class, it seems, and let's create a new column. So highlight F, right click, insert, and give it the header residential. There we go. This is where we're going to write our if-then statement that says if the crime happened in a residential area, type in the F column the word residential. If it didn't happen in a residential area, then type in the words not residential. So here is what the if statement looks like. Equal, like usual, the word if, and you can see it highlights. Open parentheses with a shift 9, and our new field, which is E2, equal sign, the word residential, and that's quote unquote residential, and then comma. So let me go over it so far. Equal if, open parentheses, E2 equals the word residential, then type in the word residential. So comma space, quote unquote, residential. But if it doesn't have the word residential in the E column, then comma space, type in the word or words not residential, and close it out. Let's go over the formula. So we have equal if E2 equals residential, comma space, quote unquote, type in the word residential is what we're telling Excel. And if it doesn't say residential in the E column, then comma space, quote unquote, not residential. Type in the words not residential. Let's hit enter and see how we fared. Okay, the first one, not residential, which makes sense because E2 is an open area. Let's copy that down. There we go. Looks accurate right there because two residentials, residential. So if we were interested in sorting it or writing a query, if we tossed it into an SQL manager, this could be really helpful because this essentially groups our E column into a more easily understandable F column. by getting rid of all those other variances. That's an if-then statement. If your cell equals something, then write one thing. If it does not equal something, then write another thing. If-then statement. We can also write if-then statements for numbers. So let's do that. Scroll all the way over. Let's practice one more if-then statement to column L, the value column. And let's get the values up top. Remember, the value column in this data was populated if it was a theft or a burglary, and the property that was taken had an actual value. This data gave me sort of an estimate to how much was taken. So I'm going to get a Control A to select all and sort, custom sort by value. And I want the values up top, so I'm going to do largest to smallest. Okay, so we have a couple of motor vehicle thefts, and they start off with $20,000. And if we keep scrolling, all other thefts, 400, I should say. Theft from a motor vehicle, 300, and so on. Shoplifting, burglaries, $75. Let's see how far it goes. Down to $5. Looks like it goes down to $1. You know. Okay, now we want to write an if-then statement. Say we're interested to see how many times a something over, say, $100 was taken. An if-then statement could tell us that. So this is how you do that. Let's start by naming column M more than $100. So more than 100. And essentially what we want to write here is I want to write the words more than $100 if the value in L is more than $100. But if it's less than $100, I want to write those words, less than $100. So here's the if-then statement for that, and I'll explain to you a little bit. Equal if shift 9 L2 is greater than 100, then write the word more than $100, quote unquote, because that's a text. I'll talk to you about text and numbers in a second. But if it's not greater than $100, write the words less than $100. And again, it's quote unquote. So you should have if L2 is greater than 100, comma, more than $100, quote unquote, comma, and if it's not, then quote unquote, less than 100. Hit enter and see if that works. Okay, 2000 is more than 100, so that's good. Now let's copy it down by clicking the magic box. And let's scroll down till we get a value that's less than $100 to see if it actually worked. 175. There we go. 70 is obviously less than 100. So right now I have less than $100. That's another if-then statement, but this involved a number. In this case, the value of the property stolen. So you'll see here, numbers don't get quotes around them. Text do. So since the value of, in this case, 100 is a number, I don't put a quote around that. But I do put a quote around more than $100 because that's text, that's words. And then I also put quotes around less than $100. And again, numbers don't get quotes around them. Text, words, they do. So that's another if-then statement. If L2 is greater than 100, type in more than 100. If L2 is less than 100, type in less than 100. And of course you could shift that around. You could say if L2 equals 100 or if L2 was less than 100. You can do any of those and then change your text accordingly. So that's another if-then statement. Now, why would an if-then statement like the one we just wrote with more or less than $100 value, or the one we wrote before with whether it was a residential area or a non-residential area, be important? Because we're not really doing any sort of analysis. We're just adding another column. Well, one, it's going to be important when we cover something called pivot tables. And pivot tables are a really powerful tool in Excel that allows you to group data together. In this case, it would be grouping all the more than $100 together and then all the less than $100 together. But think about it. It's also pretty powerful or pretty useful just to sort of filter data. Now do me a favor and try to filter on the value field. So click on value and turn your filter on. Go to home, sort and filter, and then filter. And then scroll over and do the drop down box with the value field. Now if I was interested in values that were just more than $100, I could deselect all and then click 120, 125, 175 and down the row. And that might not be too much of a pain because maybe there's a dozen or 2 dozen. But what happens if I had 8,000 different values of more or less than $100? That could be a pain. But if I were to filter on just my new field, I have 1 or 2 to select. I can filter just more than 100, and there I go. And just like we did before when we first learned filtering, select all, copy and paste this into a new worksheet, and there I go. I have just my values of more than $100 without clicking each box in the filter field. Make sense? Now I'm going to turn this filter off, and just for the heck of it, I'm going to show you the residential one as well. So turn the filter off. Like we just did, we have all our data back. And if I were to filter on the place 1 final field, filter, turn it on, I could click on residential. Or if I wanted to filter out just the non-residential, I could click on commercial place, open, retail, non-public. But again, if I had 15, 20, 30, 40 different values, that becomes a headache. So in this case, I have just 2, residential and not residential. The last formula that we'll go over today are the COUNTIF formulas, sort of like an if-then statement. And these are helpful if you wanted to count the number of times the word residential popped up, or the number of times non-residential popped up. And of course you could sort the data and sort of eyeball it, but if you had a ton of different options like apartment complex or private residence or shopping malls, then it could be a little bit of a hassle to sort and then kind of count each one. So we're going to count the number of times that in our F column the word not residential appears. So scroll all the way down to the bottom. And here's the formula for COUNTIF. So it's equals COUNTIF, and you can see how it already populates. It's sort of like an if-then statement. Shift 9 to open it. Now we're going to do our range. So our range in this case is F2 to F94,171 because that's our last cell for our records. So if F2 colon F94171, you see how it all selects, then a comma. So we're telling Excel to count the number of times between the first cell and the last cell. And now we put our criteria, and that is quote unquote equals in this case, not residential. Not residential. Close the quote, and then close the shift here to close the parentheses. So there we go, and hit enter. So 51,305 times the words not residential appeared in our data. And that could be helpful. Say we're doing stories on who gets robbed or where all these incidents in Mecklenburg County happened. We could say, well, 51,000 times that they happened in non-residential areas. So let's do one more count if statement and count the number of times that a property value of more than $100 was stolen. Now we already did the if then statement to sort of create our own column, and that was in column M right here. But if we wanted to just get a raw dollar or a raw number figure on how many times out of all these values that it was more than $100, like 175 right there, let's write an count if statement down at the bottom, and it would mirror the one that we just wrote. So you'd start equal count if, then do your cell range. So in this case it's L2 colon, and we can go all the way down to the bottom. So L94171. All our data in L is selected. Great. Then it's comma, and we're only interested in values that are greater than 100. And you can switch that around. I just chose 100 for the heck of it. So it's comma, space, quote, the greater than sign, 100, close quote, close parenthesis, and you should have this formula. Equal count if, open parentheses, L2 to L94171, the last cell of our data, comma, and then quote unquote greater than 100. So count how many times something is greater than 100, hit return. There you go. So 14,033 times something valued at least $100 was stolen. And again, you could change that up to value less than 100, value more than 500, where the value equaled 1,000. But that's a count if statement, and it's an easy way where in your reporting you could say that maybe the average value of something stolen was X, fill in the blank, but 14,000 times something worth at least $100 was stolen. So that's the count if statement. I feel like we went over a lot today, and we'll have to come back and spend more time on some of these formulas because they're a lot to take in. But as I mentioned before, some things that I always like to do is after I am done writing formulas or queries, to put those formulas or queries into Word so I don't forget about them. So here are some of the topics that we touched on today in sentence form. So we have Charlotte-Mecklenburg Police solved around 36,000 of the 94,000 cases that had opened in 2018 according to an observer analysis. That's when we looked at the case opened or closed data. On average, it took the police about 18 days to close a case. Remember, we did the average days it took after we did the date diff? Around 51,300 incidents took place in non-residential areas, data show. Now that's from using the count if statement, and also using count if statements we have more than 14,000 times property was stolen, the property was valued of at least $100. So that's just some of the formulas that we wrote in sentence form. Because after all, we are journalists, we are reporters, we're not statisticians. We want to put it into words. And a little bit of a review, since we went over a lot. We looked at the trim function to get rid of all those blank spaces so we could write our queries and have it look normal and not 15 or 16 blanks in between the block number and the street name. Then we did the date diff formula, which was equal date diff, starting date, comma, ending date, and quote-unquote D for day. And that measures the time between two dates. D stand for day. If you would substitute an M, that would be how many months were between the two dates, or Y for years. And then the if-then statement. If, quote, one criteria, comma, then it was a match. But if it didn't happen, then comma, not a match. And this fills in one response if a statement is true, and another if it's false. And of course, you had the count if statement. So equals count if your cell range from the starting cell to the ending cell, and how many times there was that certain text, like non-residential or residential, appeared. And that counts the number of times that that certain text appears. I know this was a lot. I know we went pretty fast, but trust me, we'll review all this, and soon we'll put it all together, everything that we learned, including what we're going to learn in the next couple weeks regarding pivot tables. Smash everything we learned together to clean up the data, to analyze the data, and put our functions into paragraph form. Well, that's it for today. You guys have a great day, and let me know if you have any questions or need any help, and we'll keep hammering Excel in the coming days. Thanks, guys.